Hello everyone, welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to see how to use TensorFlow and deep learning to be able to identify bias in media news, right? So that's a basic understanding. So we'll be trying to predict the presence of bias in news, and then also the political ideology behind a particular news item, whether it is to the left or to the right, concerning the left-right political spectrum, which refers to this, right? So if this one, right, whether something is more to the left or to the right, that is a particular political ideology spectrum. Or if you go to politics 101, so leftists are people that are socialists, collectivism, division of wealth, class division, protectionism. And then the right is capitalist, individualism, retention of wealth, class retention, and then free trade. So we're trying to see how to detect bias in media. So this is very useful. And then if you go to this particular website, which is Ground News, they give you the news, and then they give you the particular bias level, right, or the particular spectrum. So we have left, center, and then right. So that is the basic understanding. So this is a new one. So Twitter Blue probably being back, you can see that this is left, and this right, and then center, right. So center means it's in between. So that is the basic understanding. So let's see how to build a deep learning model to be able to detect the presence of this particular political spectrum in news items. So I'll go back again, and we are picking the data set from here. So this website has a lot of research on it, so you can check it out. That is where we got the data set from, and that is what we'll be doing. So let's start first of all. So this is using deep learning, right, TensorFlow. So I'm going to import my EDA packages, that is pandas and numpy, and then I'm also going to import my machine learning packages. So this will be used later on in case you are doing the machine learning aspect. And then you also import our deep learning TensorFlow packages. We are using Keras 2.9, right? Perfect. So let's start with this. So I'm going to first of all load my dataset. So we load the dataset. It's going to be df, then pd.read underscore csv. Inside here I have my data. Then inside my data I have my dataset here. And this dataset is column separated, or comma semicolon separated. So I have to put this one here. And now if I go back and I check it out, we can see our dataset. So based on the dataset, you can see that we have our test column, and we have the political ideology type here, and then the presence of bias. So we also do that one later. And we also have the article itself. So we'll be combining the test and then the articles to make it more robust, and then we'll be predicting the type, right? Not the bias for now, but the type. Perfect. So let's see the columns. So get the columns. So df.columns, get the columns, and then so we are picking the test, and then we are combining it with the articles, right? And then you predict the type. Okay, so let's check the shape. So df.shape, and then if I go back, I can also check the class distribution. So let's check the class distribution. So we can use seaborn.count plot, and I'll pass in my value, which is going to be my type, and then I'll just move on and then pass my data. So data is going to be my df. So if I print this one out, you can see that it is almost balanced, right? So there is more on right, and then there is also, so right and left are almost the same, and then this is center, right? We can also get another plot in which you are comparing the bias level. Also there is also bias. So if I go back and I change this one from this to this, I'm going to change it from this to my label bias. If I check it out, you see that we have the bias level, right? So I want to check the proportion of bias and non-bias within all the various levels. So we can use cat plot to help us with that. So I want to check. So it's going to be class distribution for the type, right, and then the bias. So in that case, you can do is sns.cat plot, right, and I'm going to pass in my rows. So in that case, it's going to be this option. So I'm going to have my cat, then I'll pass in the label. So s is going to be my label, so label bias, and then I can now just give the hue. The hue is going to be the type, and then I'll pass in my kind. So the kind is going to be count. So using count plot, and then I'll pass in the data itself, which is df, right? So with this option, I can actually plot it. So let's give some height, and then we give an aspect ratio. So let's give the height of, let's say 7, and then the aspect of 2, right? Now let's plot it. So plt dot, let's go with s-text to give us the rotation is equal to, let's make it 40, and then let's plot it out. So perfect. So you can see the result we have. So this is a proportion of the types in the bias. So you can see that within the bias there is more of left, right? So it is mostly, the left is mostly biased, and within the non-biased there's also more of center, right? And it makes sense. Okay, so let's see how to move on from there. So before we move on to the machine learning aspect, I want to see the amount of words that make up the bias, or that make up the particular types, right? So that's what you want to do. So what I want to do is that I want to check the composition or frequency of tokens per each type, right? So the type here means the political ideology or spectrum. Let's make it like that to make it simple. So that's what I want to check. So we'll be using, first of all, let's clean and remove all the stop words from it first. Going to do some test cleaning, test pre-processing, and what we'll be doing is that we're removing stop words, right? So let's see what I'll be doing, what I mean by that. So let me change this one to this, and then let's work on it. So we'll be using neat test to import neat test.functions as NFS, right? And then we use neat test to clean out test. So I'll just go back and let's check for missing values, any in our data set. So df.isNA.sum. So as you can see, our news link has 19, our article has 105, but as I said, I want to join the test and the article together, so we have to fill this 105. So we can drop it or we can fill it, but let's fill it. So I'm going to combine them together. So we have my test, right? I want to combine the test together with the df. I want to fit with this one article, right? So this one fill now with unknown because we don't have no article. In case you have any question or contribution, you can put inside the comment section below. So this is what we want to do, right? We want to fill this one with unknown and then pair it up, right? So this is going to be this option here. So df article, right? And then I'll join them together with this. To join this one, so this is going to fill it. So if I go back again, I do the isNA.sum, you can see that now it has filled it, right? So we don't have any missing values there. It's a lot, but yeah, let's do it like that. And now I want to combine this one. So I'll combine to 2. So I'm going to be combining this one into 2, which is going to be my, so df, let's call it as document, right? You can call it corpora anyhow you want it to be. So you're joining them together, and then we'll be using this document for our stuff. So let's clean them. So I want to clean the documents with neat test. So we can just go, if I go back DRL NFS, you can see that we have several functions that we can use with neat test. So neat test is a very powerful package that has all of these things. So what we want to do is that we want to remove, you can remove custom words, patterns, emoji, emails, hashtags, but I want to remove stop words, and I'll leave the remaining for the deep learning aspect. So let's remove the stop words from it. So this remove stop words. So in that case, it's going to be this option. I have my df documents dot apply. Then let's use lambda s. Let's nfs dot remove stop words. So remove stop words. Then I'm going to pass in let's pass in this dot lower. Let's convert entire stuff to lower case, so I'll be able to move as much stop words as we want. Right, so this is going to move all the stop words. Now I'm going to take this one here and let's call it as clean document. Right, so clean document. Now if I go back and I check it out, so we have those ones cleaned well. As you can see, right, so just clean it well. Right, perfect. See, the S is normal here. So now we want to plot them. Want to plot a word cloud, right? A word cloud for the distribution of the words for per each of them. That is what we want to do. So how do we do that? So I'm going to first get the entire stuff. So let's say center docs. I want to get all the words that belong to the center column, right? The center political ideology. So it's going to be this option here. I'm going to get my type. The type is equal to center, right? So this is going to give us all the part of the document that has this type as center. And this is only center. Then I want to get only documents, so I'll just go with this here. I want to get only the clean document aspect, so clean document. Yeah, so this is going to give us the entire stuff, and I want to join them as a list. So let's dot join. Then let's convert it to list. Right, so you are converting the entire stuff, you are joining them together as a string. So the reason it's giving us this error here is because can only join an iterable, so we have to convert this one to an iterable. Okay, so let's do the same thing for the right and then the center. So this is going to be the right, and then the next one is going to be for the left, right? The leftist. Perfect. So let's plot them. So I have already created a function to make it easy for us. So I've already created a function. So from word cloud, import word cloud, right? And then these are the functions, right? So the first one is that we also need to get, so from collections, import counter. So we are going to, we can use any of them, right? But I want to use just the word cloud to save us time. So what we are doing is that we are going to get the text, right, and use word cloud to generate it. We're going to plot it out in a nice way, right? That is the basic understanding, right? So I'll just go with for the words. So plot for center, right? So it's going to be my plot word cloud, and I'll pass in my center docs. So it's going to plot it perfectly for us, right? Very nice. So you can see that center, right, that is neutral, has the words Republican, state, people, right, year, time, date. So this is not women, Democrat. It's not that shifting to any political ideology concerning this data set. Let's move on to the other one, which is going to be for the left. You can see the difference between this. So it's having the word said so much here because this is news. There's people, Trump, Donald Trump. I don't know whether Donald Trump is leftist. I have no idea. White House, group, country, don't. Right. It's funny. And then let's move on to the right. So right is going to be mostly, let's check it out. People, they're still said, right? Time, state, Trump, Democrat. So this is some very cool stuff. You can also get the plot, as I say. So plot not word cloud, but most common words. Common token. Now passing my, let's say, hope this one works. Yeah, so we can also plot it out. So this is plotting the most common words here within most common tokens is said, right? There's a lot of said. Yeah, we have to do some cleaning very well. And you can also do the same thing for plot the most common tokens for, let's say, the left. You see the difference? Said is also going to be, there's Trump here, right? Trump people president news. So this is something very simple we have done. Now, this is some simple exploratory data analysis. Let's move on to the deep learning aspect. So this is going to be our deep learning. I'm going to build deep learning, right? So how do we build a model? So concerning this, in building with TensorFlow, there is a very nice package to help us with our vectorization, converting our text into numerical values or vectors so that we can feed it into our model, right? And the name of the package is called Test Vectorizer layer. So this is another layer. It's a new stuff that has been introduced into TensorFlow from Keras that allows you to be able to do this one. So you don't need to go through the pattern of the sequence, text to sequence tokenization. No, this is just one. It's going to replace all of them. So previously you would have done tokenize, then you would have done text to sequence, then you'd have done pattern, right? But this is going to replace all of them, clean everything and do everything for us, right? So that is what we're trying to use. So let's see what I mean by that. So the simplest approach is that I'm going to get the labels and the features, right, before we move on. So let's get our features and then our labels. So simply put, you just go with this my option here. So let's get my S features, or we can just get the label, right, and map them all. So label dict, going to do some simple encoding, which is going to be this option here. So V and then K for K, and then V in enumerate my type, which is going to be, so the reason we are doing this, perfect. So we are going to get our labels. So if I print this one out, my label dictionary, right, 0, 1, 2. So we'll be using this one to encode our labels, right? So in that case, it's going to be my S labels. So we have my S features, as we always do, which is going to be my df. Then we just use a document. You can also use a clean document if you want, but we want to, let's use it. Yeah, we want to keep it there, or let's use a clean document. Yeah, you want me without the stop words, and then I'll just go with my labels, which is going to be my df. We have my type. Then what I want to do is I want to map it with my label dict so that it converts the entire stuff into a dictionary, right? So if I check it out, now we have it in this particular format, right? Perfect. So that is what we have done. So now we have gotten our features, we have gotten our labels. We have to work on the splitting, right? We will split them first and then we vectorize. So let's split data sets. So it's going to be my all the S together, S train, Y test, then Y train, and Y test, right? Which is going to be my train test split. I'm passing my S features, my Y labels, and then let's give the test size of 0.3, and then let's give the random state of 42. So you have splitted our data set. So you have splitted our data set. Now let's go with our test or feature engineering. So feature engineering, right, using Keras. So this is what we're trying to do. So with a new model of the Keras, we have this particular model called Keras dot layers. dot test vectorizer, right? So if I go with this option here, let's explain it. So it gives you this very wonderful stuff. You have the maximum tokens. So the maximum tokens here refers to the maximum amount of tokens, right? So it's 5,000, 3,000. You just specify. Standardize is a format of the way in which we clean our data, right? So I want you to convert everything to lower case and then strip off punctuation. Of course, here are several ones of them. Then split means tokenize it in a white space. You can also use a different character. Then n-grams. We have the output mode, integer, right? You want to get the output mode into integers or float. Output sequence length, that is the length for the padding or part to mass tokens. And then you also have the rest, right? So that is something very basic we can work with. So you can also change the output mode here into count. So this is normal integer, but you can also change it to count, to TF-ID and the rest, or to multi-output. So let's work on it. So it's going to be my test vectorizer, which is going to be my keras.layers.test vectorizer. Then I'll pass in my max token. So we can just give it as none for now. You can give it a particular value. It can be, say, 3,000. Yeah, you can make it 3,000. You can make it 4,000. Anyhow you want it to be. Then the standardize. Let's put it as you know, out lower, convert it to lower, and then strip punctuations. So we are leaving the test cleaning to pandas, punctuation to keras rather, to pandas. And then I want to split the entire stuff on white space. So the tokenization is going to be on white space. Now specify the output mode. So the output mode in this case, we can just put it as my count, right? So count vectorizer. You can also use TF-ID if you want. So it's giving us some error, but yeah, because I don't have CUDA, but it's still going to work anyway. But that is the first one. So we have gotten the maximum number of tokens, the lower strip, the splitting, and the rest. Now let's move on from here, and then let's work on if I go back, let's work on the adapting. So adapt is, in this we are going to create vectors from it. So create vectors from the data, right? So it's going to apply whatever you have done on it. So in that case, it's going to be my test vectorizer dot adapt, and I'll pass in my value, right? So this is where the learning goes. So I'll just pass in my string. Then I'll specify the batch size. So let's put that 5512. Can give it any value. So it's going to adapt it, right? It's going to pick the data and then work on it, do the magic behind the scene. Now from that we can get the value. So in case I want to get the vocabulary, I can just go with my, let's go to vocab, which is going to be this option, my test vectorizer. Then get vocabulary. So you have get vocabulary, you can get the weight. And if I go back and I print it out, you can also print the vocabulary out. So let's say I want to pick the first 5 vocabularies. Yeah, so that this is the first unknown said Trump people. That explains why I said it was seen most of the time in our data, right? Very simple. So now we have built something very simple. Now let's move on and then build our model itself. Model. So I want to build a model. So to build a model is very simple. I just go with my test. We already have our test vectorizer already, right? So now I have to build a model simply. Now before we move on, let's get the classes first. So the class or target, right, which is going to be my classes. It's going to be my y train, right? This is what we want to get. We want to get the value of the entire stuff. So np.unique, then get the entire stuff here. So if I go back and I just go with my classes, you can see what you have 0, 1, 2, which is the same as the label that we had. And now I just build the model. So you're using sequential model, you are building them sequentially. First layer is going to be 1, right? And we're going to pass our test vectorizer, which consists of our training data, right? Already here, you can see the training data is there, and then going to put in the output. So the output is going to be 3, which is the one you are putting here. We are using soft mask because it's a test classification problem. Okay, so it's going to return our model. That is the first thing. Now let's create the model. So we're creating a model. So to create the model, just go with my model. Now just go with my create model. Now pass in my test vectorizer. So I'm going to create a model. Let's move on from here, and then let's get the model summary. So model summary going to be model.summary to see what you have built. If I go with this option here, you can see that we have our sequential model, which has the first layer as test vectorizer. It has a dense layer, and then the dense 1, dense 2, and the output is 3, right? These are the number of parameters that we are working with. So we can also plot it in case you want, but let's compile it and then make our prediction. So we'll be compiling it. So let's compile. It's going to be my model.compile. Then I'm going to pass in my stuff. So I'll put in Adam, right? Adaptive. Then sparse. So sparse cross. The reason we are using this is because it's a test classification, multiple classes, categorical, cross, entropy, right? I hope the name is correct. And then we're going to pass in the metric that you want to use. So the metric you are using is, we want to use accuracy as our metric. Yeah, and now after I've finished compiling, let's train. So it's going to be my model dot fit. I want to fit it on my S train, and then my Y train, then my batch size. Let's keep the batch size of, let's say 256, and then I also want to give the epochs of 10, right? Just 10 epochs. And then we can just pass in the validation data, which in this case going to be our S test, and then our Y test, right? So that's something very basic. So let's store this one into history. Let's put it. So it's giving us an error because I forgot to close it here. So first one. So the reason it's fast is I have GPU, and it explains why. But I don't have CUDA yet installed properly. Perfect. So we are done with it. Now let's get the accuracy of the model. So this is the accuracy. Wow, 99. That is good. So we want to get the accuracy. You can also evaluate it, but we'll be leaving that one later on. So to get the accuracy of our model, we can just go straight away with this option. So model, right, dot. So let's call this Y predict. So model dot predict. Then I'm going to pass in my S test, right? We are predicting it. I want to get the accuracy of it. Then, so we have gotten our value. So in case I want to get accuracy, let's go with my accuracy score. Then I pass in my S test, or Y test rather, because yeah. And then my Y predict. Right. This is one way, but now let's go with np.agmass to get the score, to get the argument, and let's give it access. So access is going to be 1. So 1 means it's going to go to the pick the last, right? So yeah, perfect. So the accuracy of our model after checking it is 88%, which is very good. Perfect. Now let's see how to make some predictions. So in case I want to make a prediction, so make prediction. Before we make the prediction, we can also do evaluation of the model. So let's evaluate it before. So print, then we have my classification report. Then I'll pass in my same thing. Let's pass in this here. Right, I want to pass in this value here. Perfect. And then from there I can also move on to the target names. Let's put in the label, dictionary keys. Yeah, I don't know why I'm always not stopping the compression. So you see that the center is 85, left is 92, right is 86, right? That is the classification report. Let's make a simple prediction. So in case I want to make a simple prediction for the entire stuff, it is very simple. So before I make the prediction, I'm going to pick one from the test data. Let's pick let's pick the first one. 0, which is this one, right? Which is about transgender, right? And then we want to get the value, the prediction of this. So this, I want to get the prediction, which is going to be y, and it's 2. 2 in our test here. If you go back to the labels that we had, 2 is right. I don't know. Yeah, it's saying it's right. So let's see whether it's going to actually give us the same thing. If I go back to this, oh yeah, let's go with this 2. That means it's right. So I expected it's supposed to be right, the right part of the spectrum, political spectrum. And now let's predict. So model dot predict. Now pass in my np dot array. I have to reshape the entire stuff. So s test dot ilog 0. Perfect. And let's reshape dot reshape. So I want to reshape it to this option, this one, to get in a better format. And let's predict. We have gotten our result, right? So how do you know which one it belongs to, right? So we can easily convert the entire stuff using argmax. So let's cut as my prediction, and then just go np.argmax. Then I'll pass in my prediction. You can also give the access. Go to 1, 2, right? So we expected it to be 2, and our model has predicted it to be 2, right? Perfect, right? So that means that our model is actually working. So let's pick an example from here. So Twitter blue, this is this right. Let's pick this one. This is right according to ground news. This is a rightish, right? To the right, yeah, 71%. So we can just copy this. So I'll copy this one. Let's try it on. It's going to be our sample, and then now pass in the other form. So let's pass in here. Let's see if with this little one we can get the prediction as right. Hopefully, if there are more news on it, we'll see if we will be able to get. Yeah, so there's the news. Let's see whether we're able to get more information about it. Yeah, but since it's not coming, let's go with this one like that. Okay, so we have gotten something like this. I want to predict. So just as we did here, we can also go according to what we had in our news item. This is supposed to be right. Right. It's supposed to be right. So that's what you're expecting. You're expecting it to be right based on ground news. So I'll just pass in my example 1 here, and we got it. So let's get the argmax of it to get a prediction. Just 0. It's funny. It's 0. I don't know why it's giving us that. Yeah, it's 0. Maybe because the data is not as much as we want it to be, right? But it gives us as 0. And it's quite interesting. Let's get the percentages. And let's get a percentage with this option here. So 0, 1, 2. Okay, that explains why. So it is mostly center, right? So that means it's not very biased, but the news item said is center, okay, and then right. Yeah, so you move on. Like now, having done that, let's explain it. So this is going to be explanation of model. We'll be trying to explain this particular model using Shap. So to save us time, we'll be using Shap to help us with that. So import Shap, and we're using Shaply to be able to help us interpret this model. So what you're going to do is that we are going to create a masker, which is going to mask some of the words. So Shap.maskers, right, .test. Then I'm going to pass in my tokenizer. So let's use the regular expression of R. So backslash, where is it? Backslash 1. So it's going to be using words as regular expression for the tokenization. That is the default anyway. Okay, so Shap.maskers, right, .test. Then we'll be using this one to mask our work. Then I'm going to create our explainer, which is going to be my Shap.explainer. Then I'll pass in my model that we have. Then my maskers is going to mask, right. Then I'll put in the output. Let's give the class's name. So this is going to give us our explainer. If I go back to my explainer here, just created a Shap partition explainer, and then we will use this one to make our prediction. So how do we predict? Right, to predict is very simple. I'm going to go back again and do this option here. So to predict, it must take in an array, right? So this is our example here. So we had that example here. It must be committed to an array, right? Just like in scikit-learn. So it's going to be my Shap values. Then I'm going to pass in my explainer. So explainer dot, I'll pass in this option here. So let's pass it in here, example 1. So this is how it's going to do. Hopefully it doesn't fail. Pivot, and in case I want to plot it and explain, so we want to interpret it. So interpret the model with a plot. Simply you go with Shap.plot.test. Then you pass in your Shap values. That is how to do that. So if I go with this, it's going to explain it for us, right? So it gave us 0, right? So that means that is why the prediction was 0 here. That means it is mostly to the center. And then if I come back here, you can see the words that actually depict that it is center, right? So all of these sums, so if I put it here, you can see it's selecting it. So disappointed is 0.5, half is 0.18, and then the rest, right? So this is the basic understanding behind it, right? Election, right? So it's going to combine all of them to give us the sum. So that is how to do text classification using deep learning and TensorFlow. You have seen how to interpret this particular model. You can also do more in case you want, right? But that is something very basic I've done so far. So let's try, in case I try the same thing with the one we had, which was this one here, this one that we had here, right? Remember that we had this example, this one, yeah, right? In case I want to also explain this one, I can just simply do it this way. I want to explain it just as we did above here. We can also simply explain it with this. So Shap, so the same thing we did. So Shap values 2 is go to my explainer, and I pass in this value here that we had. Remember that this must also be in a format of a list, otherwise it's going to fail. And then I can now interpret it. So let's interpret why it gave us that value. So this is going to be 2, and you can see how nice it is, right? So it's going to tell us which part of the sentence contribute to give us the prediction of it being to number 2, not to number 1, 0, not center, right, but to not to the left but to the right, right? These are all the keywords there. He, him, all of these words, right? Very cool and very nice. That is something very basic. So thank you for watching this tutorial. See you in the next session. Stay blessed. And check the links below for some interesting material to help you master machine learning and Python. So you can also save the model and then use it for some other stuff. See you another time. Stay blessed.